Now let's dive into Snowflake's data storage layer, which plays a critical role in its multi-clustered shared data architecture. Snowflake stores all the user data and query results in a central location, such as Amazon S3, in a format optimized for performance and scalability. The design means that data doesn't reside within the compute nodes, but is accessible to any compute node as required. One of the unique aspects of Snowflake's storage approach is its use of micropartitions. Data is stored as a set of immutable micropartitions, which are essentially small, manageable chunks of data that are independently stored. These micropartitions typically range from 16 to 64 MB in size, which allows for efficient storage and retrieval of data. By organizing the data in small, immutable partitions, immutable is the important word there, Snowflake enables rapid access, efficient caching, and minimal data movement during queries. Snowflake leverages a tiered storage approach with Amazon S3 at the base layer. S3 provides a highly durable and available object store with 11 nines durability, meaning that the likelihood of data loss is nearly zero. It offers a straightforward API for reading, writing, and deleting objects, which Snowflake uses to store and manage data efficiently. The base layer of storage allows Snowflake to focus on compute resources for query processing without having to worry about the data durability or availability. Storing data in a centralized object store has additional advantages. For example, if user shuts down a virtual warehouse, they don't need to worry about losing access to their any sorts of data. The data remains safely stored and can be accessed whenever they start a new warehouse, giving users true pay-as-you-go flexibility and peace of mind knowing their data is secure and accessible. Snowflake's storage layer is designed to optimize performance while minimizing operational overhead, making it possible to store, retrieve, and manage data seamlessly without complex configurations. On this side, let's take a closer look at how Snowflake organizes data within the storage layer, specifically focusing on the table files. Snowflake uses a data layout called PAX, PAX, or hybrid columnar format, which is based on a well-known format from the database literature. In PAX storage, data is stored in columnar format, meaning each column's value are grouped together rather than being stored row by row. This columnar format is advantageous for analytics as it enables high data compression and speeds up query processing by allowing selective reading on only the columns needed for a given query. Data in Snowflake is divided into micropartitions, each representing a horizontal partition of the table. Similar to sharding approach in other systems, each micropartition is stored as an immutable file in a centralized storage layer. With, when updates are made, Snowflake does not modify the existing files but instead creates new micropartitions to reflect the changes. This design choice enables faster data access as micropartitions don't need to be locked or rewritten, and it simplifies Snowflake's approach to concurrency control, which we'll discuss in later slides. One of the biggest advantages of this approach is that queries can load only the required data, required columns within a partition thanks to the lightweight header on top of each micropartition file. This header contains the metadata about the partition, includes offset to each column when the file within the file, and so on. Snowflake's system can then selectively read specific parts of the file based on this metadata, making it unnecessary to load the entire file into the memory. And this is the efficiency that Snowflake has. This micropartitioning approach is an essential part of Snowflake's performance model. It enables efficient data retrieval, high compression, and fast query processing, all while keeping the storage layer simple and scalable. Overall, this columnar micropartition storage format ensures that Snowflake can handle large volumes of data while keeping the queries performant, giving users an efficient and seamless data warehousing experience.